Hey there, welcome back to another video. Today we're going to rip into a Ford AOD, and so the backstory here is that this transmission came out of a 1967 Ford Mustang, so it's a resto mod swap, and the trans itself was rebuilt back in September of 2022. However, it sat for a while, probably a good year and a half, and then was only recently installed back into the car. And then for whatever reason, the shop that did the install either did not set up or install the throttle valve cable, TV cable, or was just simply poorly adjusted. Either way, the transmission quickly lost third gear, is neutral in third, and so the owner took it from that shop, brought it to another shop who is my immediate customer here, and the shop that I'm working with, they tried to, I guess, set the TV cable correctly. They did what they could, but unfortunately they couldn't bring third gear back. So neutral and third condition, that's the main reason it's on the bench for tear down, and we'll be going through. All right, so quick history on the AOD. They came into being in 1979 and went out of production in 1991. They were preceded by the FMX transmission, which is the 3-speed, and they were superseded by the AODE, which is the electronic version of this unit, and the ultimately the 4R70 75W, and that rounds out this family of transmissions. So the AODs didn't see a whole lot of updating throughout their life cycle. The very, very early units, I think, had a couple thrust washers in place, Torrington bearings, but other than that, they're largely the same. So this particular unit came out of a 1989 LTD, and what I'm taking that to mean is Crown Victoria. And so I'm hoping everything's good inside. There really shouldn't be any hard part damage, given it was recently rebuilt and just had a soft part failure in the direct. But anytime you have a transmission on your bench where you know for a fact that it has been previously gone through, you want to be on heightened alert, because there's always a possibility that something could be installed incorrectly or missing. So you really want to pay close attention to things like end play or travel checks, clutch clearances, orientation of different parts like bearings, and or thrust washers, and really anything else that might seem out of the ordinary. All right, you're also going to be on the lookout for modifications, whether popular or otherwise, to different things like accumulators or in the valve body, perhaps the installation of a shift kit or some other hydraulic improvements. And in the case of these transmissions, the things that I would want to see would be some sort of power pack or updates to the direct clutch. That's a known vulnerability or area of weakness with these things, as well as you want to make sure that they replace things like the servo and for reverse, or using the correct servo, because they are different. There's different length of pins that you get, so paying close attention to band clearance will be critical. And then same with the overdrive, you want to make sure that everything there is tended to. All right, the first things that we're going to take off this transmission are going to be the neutral safety / reverse backup light switch, the extension housing, then the governor. And then from there, I'll go ahead and flip it over. We'll move, through the pan, the valve body. We'll take a look. Hopefully, all we see is just burnt clutch material, no, kibbles and bits or metal or anything like that. I didn't notice anything in the torque converter when I was in here. I drained it out. Nothing unusual came out of it. So hoping that this is just a soft part failure. And then when we go back with it, we'll put all new soft parts in it, new bushings, and there's a few other updates that I'll chat through as we move through the case that will make sure that you want to do on overhaul, just areas of weakness that you want to address and risk you want to mitigate. All right, for the neutral safety switch, you just need a 3/4 wrench. I mean, you could zip it out with an impact and a socket, but I like to use wrenches on these because I'm paranoid about somehow damaging the little pins. These things are otherwise resilient, and you can reuse them. You can get them new too if you need to. Just make note of the O-ring that's there on the end, and then from there we'll go ahead and yank the extension housing off. So 13 millimeter. And if there was a rear trans mount, these bolts get 3/4. Okay, make note of this little ID tag. I'm going to be perfectly honest with you, I have no idea what those letters and numbers mean, you know, what the codification here is. Once we get done with this area over here, I'll point out how you can identify the year, the application of your AOD, or really any Ford transmission, using the date stamp or casting stamps here on the driver's side of the case, just aft of the selector shaft. Okay, 6 bolts in total, 13 millimeter. It looks like they glued this on. It's totally unnecessary to do. Okay, this gasket can go on as is. It already has sealant, and it could be that this is what is holding it in. So maybe they didn't glue it. Maybe it's just the sealant kind of melting. So right here is where you would have your speedometer assembly. I'll flash a picture of what that looks like, but it looks like this particular unit, the speedometer stayed with the primary shop. The gear, I should say. All right, next you have your governor. So you're going to have a large snap ring here, and then when you take the governor off, there's going to be a little detent ball in this location right here, and there's going to be a little recess for it on the output shaft where it'll sit. If I could bring this around and show you the detent ball. Hopefully you can see that. Okay, this thing's full of fluid, so. Some of these have like a little oil dam or oil slinger here. If yours has it, you don't need to do anything with it. It's not going to interfere with your ability to remove the snap ring or the governor. All right, the governor will be taken apart and, you know, checked out, inspected, and ultimately overhauled, just like any other sub-assembly. And then here's your ball. And normally these don't stick in here like this. I'm not sure why this one's being stubborn, but it's got to come out so that ultimately the output shaft can come out. Alright, next, if you have it, just undo your little nut here for the selector. That was finger loose. Alright, then we'll come over to the front of the case. So, like any other transmission that has some sort of front end plate measurement or travel check, you want to make sure that the unit you're working on, the end play itself, the travel that's there, makes sense based on what you know the specs to be. These take 40 to 70 thousandths. Okay, that's what your end play range should be for the V8s. I think for the V6, it's something like 30 to 65 thousandths. But what you need to do is take a set of vice grips and just kind of push and pull on this secondary shaft. This is actually technically your input shaft, and this shaft here is going to be your direct drive shaft. So, meaning it goes from the direct drum directly to the torque converter. The AODs use what's called a split torque system, so it's kind of an idiosyncratic means or method for engaging and locking the torque converter in third and fourth gear that is organic to the AODs. The AODs for our 70 and 75Ws went back to a traditional torque converter clutch lockup design where you just had a single input shaft that's, you know, passed through the stator like most any other transmission. Okay, so first thing, if you want, you could take the direct drive shaft out and you want to inspect the splines. Okay, inspect the body. Worn splines here, especially on the rear set, this is the rear that came out of the direct drum, would indicate that the direct drum splines are also worn. And that's one of the most common failure modes for these particular transmissions, is having the direct drum spline strip, and then you have no third and no fourth gear. So we'll pay very close attention to the direct drum once we, you know, have it out of the case. So you can also check wear using your drive shaft. So, you know, keep it handy, because we're gonna, you know, we're gonna grab it later once we have the direct drum out and see if there's any play between the male splines of the drum and the female, excuse me, the male splines on the shaft and the female splines on the drum. For now, what I'm going to do is take a small pair of vice grips, and I'm just going to attach them to the input shaft. I'm going to see if I can get it in the area of the starter cut out so I have a little bit of room. All right, now it's going to float like this in the case. You see this kind of lateral play, that's normal. So just like any other shaft, put it all the way in and then pull out. Okay, that feels a little tight to me. I mean, it's also laden with fluid, so that could be kind of influencing how it feels, but it definitely feels a bit tight. Now, the way Ford has you measure the end play on these is a little different than most other transmissions. So this transmission family uses a combination of selective washers that go behind the pump and the depth measurement from the deck surface to the reverse input drum's thrust surface. And based on whatever that depth is, they will give you a range that corresponds to a particular thrust washer number for the back of the stator, and that's what you use. But whenever I build these, I go by that, and then I go by the actual measurement of the travel, and that tells me where I'm at and what I need to do, if anything, to get end play where it needs to be. So that's basically it as far as the end play travel check. Next, just check your splines. You also want to rotate, just like anything else, you want to rotate the input shaft, make sure you can move it clockwise and counterclockwise. It should not be bound up. Okay, you can do the same with the direct shaft. So if you want, you could put it back in. And then same kind of deal, make sure that you can turn the direct drum to and fro. Ensure that there's no binding or galling or funny noises. All right, now what I'm going to do is I'll show you, actually let me show you the codification. I want to make sure I hit that before we go any further. So I'm going to zoom in on the case, and then we'll walk through what these letters and numbers mean so that you can determine, if you don't already know, you can determine where a particular Ford transmission came from, what the application was, and this way you have that information if you don't already, you know, have it because it, you know, you're pulling it out of the vehicle that it was originally installed in, you know, at the factory. All right, we're all zoomed in, so I'll just cover the first 6 characters. RF simply stands for Rouge Foundry, and then you have E9DP. E indicates the decade of production, while the integer equals the actual year. So in this codification, you have C for 1960s, D is indicative of 1970s, E equates to 1980s, and F equates to 1990s. So this would mean that this is a 1989 transmission. Okay, D indicates the application or submodel. So looking it up, it corresponds to either a Granada, which was like a four-door sedan that was in production from the 70s to the early 80s, or an LTD, which I'm taking that to mean that this is a Crown Victoria transmission. And then P stands for the owning office within Ford that was responsible for designing and engineering and producing this part. So P just simply stands for automatic transmission and transaxle. So if you're ever wondering, where your transmission came from, what the vehicle or what office or whatever the case, you use this codification here based on what I just shared, and that should tell you exactly where it came from and what it was used in. And that's helpful too, because there's a lot of different variants of the same transmission. Some are a little bit more optimal for others, especially for high performance or heavy duty type applications. Now Ford went to a different codification in the late 90s, and so and that codification resembled that of which GM has been using since roughly the early 90s, which is a 4-character alphanumeric code. And in 1999, this letter was X, and then 2000, the letter was Y. And then starting in 2000 up, the first character was actually the integer, which represented the year of production, and then the next 3 represented the make, model, and submodel, along with the office of design and engineering. Okay, before we go any further, I want to air check the direct clutch through the back of the output shaft. So with these transmissions, you can actually do that without taking the valve body or even the pan off. So when the transmission's full of fluid, this could be kind of messy. So you want to have like a shock towel or something or other. But basically what you're going to be doing here is you're going to be putting air into one of these feeds and blocking the other. And like I said, a whole bunch of fluid's going to come out, so I want to kind of orient this port down here, kind of facing the bench. But because we had a neutral and third condition, I want to see if we even have apply in that clutch. So just take some air, kind of put it on the nozzle. Like I said, this is going to be probably messy, so you just want to use caution, maybe put on some safety glasses or something. I may have to turn it up this way. Okay. Let's call that inconclusive. We can always check the drum once it's out, but it is an option for you if if you're investigating like a neutral and third condition, especially shortly after rebuild. The reason why I wanted to check this is because these transmissions require some specialized tools to install the pistons with the new lip seals into their respective drums, and not everybody's going to have those tools. They're not all that expensive, and the aftermarket makes the tools as well as the original Ford Rotunda tool maker. But if you don't have them, it's a lot more difficult to get all those lip seals installed. It takes you a lot longer. So, all right, I'm gonna flip this thing over now, and we're gonna let the fluid drain out of it. Get that plug out. And like I said, this thing's full of fluid, so whole entire transmission worth of fluid. If you watch my other teardown videos, you may notice that this bench is different than the ones that have appeared, or the bench that has appeared in all my other videos, and that's because it's new. Or at least it's new to me. I mean, the owner of my local transmission hard part supplier was kind enough to sell me one of his unused benches, and this thing's worked out much better than what I had here previously. So makes the job a lot easier, makes fluid drainage a lot better, a lot cleaner, and less cumbersome. Everything drains into the back there, all nice and neat. All right, let's take the pan off. 10 millimeter. Okay, this pan was already off. Like I said, the shop that took this in, they tried to do some, investigative work, see if they could resolve it by just simply dropping the pan and making some adjustments here and there with the cable, but unfortunately that did not work. All right. Okay, for some reason the pan's bonded, so whenever you have a pan that's kind of hard and fast to the case, you just want to take a flat blade screwdriver that has no grooves on the blade and a hammer, and you want to go in at a bolt hole location on the pan side of the gasket. So I always tackle this problem either here or maybe here, somewhere like that, and then just gently tap at the bolt hole location. And maybe they didn't take this pan off. All right, so we have plenty of evidence of some applied element burnup. Third clutch specifically. So it had first and second gear, and then that's it. Okay, so everything on here is going to be 8 millimeter as far as your filter bolts and your valve body to case bolts. There's two different lengths of valve body to case bolts, and then there's a couple of bolts here, the shorter ones, that are a little bit different than the others. So I'll show you once we have them all. I always install Transgo shift kits in these. So the Transgo kit has a lot of corrective parts, and it's one of those transmissions where that kind of bucks the trend where I usually say you don't need a shift kit, and shift kits aren't necessary. Here I actually like to install the Transgo kit because for you to do all the different things that they include for you yourself, it's usually not either feasible or certainly not cost and time effective. Okay, so there's going to be a little gasket here at the pickup location. Alright, another tip I'd recommend, and I'm talking to myself just as much as I'm talking to you guys, is for all your teardowns, once they come in, don't throw the filters out. Keep them so you can cut them open on a bandsaw or whatever. A lot of times, strange no movement conditions, much like the 4L60E that I have on the channel, 4L60E Autopsy, mysterious no movement or something like that. More than likely, the torque converter clutch that burnt up in that unit clogged the filter to such an extent that it was causing intermittent no movement conditions, and a few commenters had suggested that to be the case. And unfortunately, at the time I filmed it, it either didn't occur to me or I wasn't thinking about it, but I didn't cut the filter open on camera, and I should have. So I'm not going to do that here, just simply because we kind of know what the problem is, and we don't have like a no movement condition that we're trying to diagnose. It's more of just more than likely failed TV adjustment or setup causing the direct clutch to burn up. I mean, that clutch is weak anyway, so I'm curious to see if the shop had installed a power pack. I always install power packs in these. It's made by Alto, and for the AOD cast direct drums, the cast iron style, that'll allow you to fit an additional 2 frictions and steels in there. And then for the 470Ws, you can fit, I want to say, 8 frictions and 7 steels, if I'm not mistaken, something like that. But either way, it is a must-do, in my humble opinion, for this family of transmissions to reinforce that area weakness. It's not unlike the 4L60Es and 700R4s with the 3/4 clutch pack. So Same principle, you know, same kind of vulnerability. All right, so here's our 3 filter bolts. All right, so along the perimeter here, on the leading edge, you have your short bolts. You have a short bolt here, and then you have 3 additional short bolts. I'm just going to take them all out, and then I'll show you the short bolts and then the long bolts. All right, so up here in the, leading edge here by the 3/4 accumulator, you have this longer underhead radius or length of the bolt that's not threaded. All right, notice that's different than the next bolt and the next bolt. Okay, so this kind of stuff, and same with this one. All right, so this kind of stuff you just want to keep track of. So you have these bolts here, and they go in these 2 locations at the corners, and then your rest of your bolts go here. Okay, and they're largely the same. And then you have your longer bolts, and they're about maybe 50% longer than the short bolts. So you just want to be mindful of the locations for each of these lengths of bolts. Now, if you have the ATSG manual for this transmission, or at least the copy that I have, it does misidentify which bolts are which. In other words, it tells you the location for the long bolts, but they're actually the locations for the short bolts. And we got a pan bolt. All right, I will do a separate video or videos on the valve body. This filter out of the way, but here is the back side of the valve body. Okay, like I said, minimal changes to these valve bodies. As far as your, kind of, model specific differences, the Super Coupes, Thunderbird Super Coupes that had these transmissions, they did not have a 3/4 accumulator at all installed in the bore, and they had a slightly different valve body, when it came to that back side, that circular plate was a little different. All right, this thing is pretty nasty. So we'll go through this valve body separately in another video. So here's your valve body. Oops, sorry about that. Your valve body to case gasket. It is a little bit bonded to the case, so makes it a little bit difficult to take loose. Hoping it mostly comes off. It's like right there is the hot spot. All right, let me drain this pan, get this out of the way, and then we'll resume. All right, now we'll go ahead and we'll tackle the accumulators and the servo pistons. So you have your reverse servo here and you have your overdrive servo. The reverse servos on these are selective, meaning that the pin lengths are different. There's 3, and they're distinguished by the number of grooves on the pin. And you'll see that when I pull that servo out. For the overdrive servos, there are 2 different servo variants, an A servo and a B servo. The majority of these had the B servos, which is, you know, okay, I guess, for factory applications. The A servo had a lot more applied surface area and was used in some of the higher performance stuff like the aforementioned Super Coupes. So my recommendation for anything that's going to see any sort of performance or heavy duty use at all when it comes to the AOD is to take this B servo and cover and put it aside, maybe use it as an ashtray or something, and install something on the order of either an A servo if you have a factory A servo assembly available, or a billet servo from the aftermarket. Sonics has a servo assembly with a cover and everything, and that's going to be way better than anything that was produced by Ford. Okay. Some of these models did not have the 3/4 accumulator, as I mentioned earlier, so if you don't see an accumulator piston in here, you know, don't panic. It's not because somebody came into the night and stole it. It's because it didn't have one to begin with. I mean, you could always check based on your application and, you know, what you know to be true, but more than likely it's just, you know, wasn't available. Okay, so here's your snap ring, comes off quite easily. And you can see if you could pull this out with a pair of pliers or something using the plunger. A lot of times it won't come out. It's hard and fast, but sometimes it will. Okay, otherwise you would introduce air right in this port and it'll pop it right out for you. I was trying not to do that because, you know, all the fluid's still in this thing, making a mess. But one of the things you want to check for is just wear here in the cover. And then just take a look here at the sealing rings, make sure that they're not cut, they're not worn or damaged. I mean, you're going to replace them anyway, but for diagnostic purposes, if you had some sort of delayed engagements or flare shifting from 3 to 4, this could be a potential source for that. All right, let's see, we have the 2-3 accumulator here. I'm actually going to save that for last. I'm going to pop these 2 out first because I'm going to try to see if I can put air into that output shaft and get the direct clutch to apply now that the majority of the fluid's out of the case. Okay, so for these, I refer to this as a 2-screwdriver job. Basically what I do is I have the case kind of, you know, belly up, and then I'll work the snap ring part way out with one screwdriver, and then I'll get in behind it with another one and just, you know, kind of use them together to pry outward. So I'm going to try that now. The disadvantage of doing it this way with the, you know, case on its side is that you don't have nearly as much leverage to compress the springs that are underneath each of these pistons. So this is the cover, there's a piston underneath, and same with this. This is the cover, and then there's a piston inside of it. Alright, so you really want to get in behind it like this, and then you can kind of press down and then pull it up, and then it'll pop right out on you. Okay, these should always be replaced. And as I mentioned, you have your ID grooves here. This is a 3-groove servo. This is the longest, the longest possible servo. So it's important that when you go back with it, you start with the same kind of servo. Okay, the same length pin, so that you put back what came out of there. Okay, even though these are technically new per se, I mean there's less than 50 miles in this transmission, I would never reuse these because everything in here got real hot when the direct clutch burned. So I'm just going to wipe it off a little bit, and then I'll just, you know, put it to the side. Alright, you have your spring and then your snap ring, and then like I said, here's your cover. nasty. Alright, same deal with the overdrive. So again, a 2 screwdriver job. I'm going to drain some of this fluid. So there's the letter B, identifies the type of servo you have. It's on the cover as well as the back side of the piston. I guess the front side of the piston, technically that's the front side. And then your return spring, and your snap ring is going to look like this. That was a street sweeping truck. The snap ring is going to kind of look like this. I mean, that's normal. All right, let me drain a little bit more fluid out. Like I said, I want to be able to apply that clutch, if nothing else, just to show you. I mean, at this point, we don't need to access the output shaft. We could just go right into the direct feed in the case. All right, so I'm going to start putting air. All right, so you see this little filter. This is for the governor. Okay, that has to go back in there. Just make note of the way it came out. So like that. All right, this is going to be your governor out. And then this is your direct clutch. So the clutch is applying. It's good apply there. So that was not our problem. And as mentioned, the shop that brought this to me said that it did drive. It just, you know, it was slipping. It was delayed engagements from 2 to 3, and then, you know, it just went out. So it doesn't take long to burn up the transmission, and particularly the direct clutch in these, if you don't adjust the TV cable correctly. All right, now let's get the 2-3 accumulator out. So just snap ring pliers. Just press on it a little bit and out it comes. All right, so they did update the accumulator piston here to the bonded steel and rubber variety for the 4R70Ws. This must be done on all AODs because most of them will have the plastic piston. You never reuse that. You always use an updated 4R70 2-3 accumulator piston that's bonded steel and rubber. All right, let's put that aside. All right, now the only other thing we have to do here on the belly of the case is get rid of the shift linkage. So one of the things I like to do, and you know, it's up to you if you want to use this method or not, but one of the things I like to do to get this nut loose is to just simply tap on the lever. I'm not going to be able to do that given where it is. So the other method, and this is something that's explained in the ATSG manual, is to take another box end wrench, stick it here on the end of the rooster comb, and then insert your 7/8 inch wrench, and then holding this in place, you just simply wrench it, counterclockwise to loosen the nut. All right, so let me go ahead and do that. I'm gonna grab my 3/4 wrench. So 7/8, and then 3/4. This could be a little bit awkward. Like I said, I have a different method I use, but I don't think the camera angle is optimal for that. Okay. All right, another thing you want to make note of is there's going to be this little stop spring here. Note how it's coiled on the back side of your throttle valve lever. Okay, so this is just going to come off just like this, and it's going to go just like this when you put it back on. And I'm just going to take it back off. And it will get stuck in there if the back of the spring's caught up. And then the last thing we need to do is grab that roll pin. All right, now whoever rebuilt this last, I mean, they seated it all the way down in there, so it's kind of making it as difficult as possible for the next builder to deal with it. Yay. All right, I'm gonna need a smaller pair of diag cutters. I mean, this thing is really, really in here. Like, this was completely unnecessary. You do not have to seat this thing all the way in to this into this hole here. I mean, all right, I'm gonna go off camera to deal with it, but essentially what I need to do is find a pair of diagonal cutters or something that can, get some purchase on this roll pin and yank it out. Okay, if I can't use that, I do have a roll pin puller that's used on 6L transmissions, General Motors 6L80, 6L90s, etc. And it's basically a roll pin puller, but I don't know if it can get down to, in there. I don't think it can, because the nub or the end of it is too broad. Okay, it wasn't designed to access these types of confined spaces, where roll pins are seated like that. All right, what I did is just modified a pair of needle nose, ground the ends just a little bit thinner so that they would fit in this circular recess, and then I'm going to see if I can pull it out with these things. Wow. So, like I said, this is why you always have to be on guard when you're dealing with a transmission that somebody else worked on, because you never know what somebody might do. And in this case, I mean, they buried this thing in here. I may not be able to take this out at all. I'm going to continue to go at it off camera, see if I can find something else to get up in there and get that thing to where it's at least part way out so I can grab it with diags or these other pliers. But I think I made it worse. going in at it, but yeah, I can't even get on it. Oh, there we go. Okay, so there's a little lip right there, and I managed to get just enough of a grip with those pliers, and it yanked it right out. Right in the middle of complaining and moaning about it, I was able to solve the problem. Alright, so just tap your rooster cone until it comes off of the shift lever, and then yank the shift lever out, and then go ahead and yank everything else out. Alright. Alright, there is a selector shaft seal. We can take that out too. Ford makes a special removal and install tool just for the seal. I actually have the install tool, but you don't need the removal tool. Just a little pry bar is sufficient. Alright, get these tools a little bit out of the way. I need to remove that pump removal tool. May end up using it on this thing because the procedure here is once you have all these bolts out, you thread in 2 bolts on the threaded locations on the pump body, and then you use a slide hammer to just smack them out. I don't feel like pulling the slide hammer out, so I'll show you one of 2 methods, depending on which one of them works, to get this pump out, because the pump bore to the deck surface here is very shallow, so it's not like you got to negotiate a big cavity to get this thing out of the way. So 10mm bolts. Okay, all these pump bolts are the same length, same thread pitch. So the first method to getting this pump out involves tapping the stator. So all you're going to do is gently tap the stator from side to side until you could free it, and then you're just going to yank it out. Okay, sometimes it works, sometimes it doesn't. If it doesn't work, continuously beat on it. You don't want to force anything. So the next step is to take your direct shaft and reinsert it, and then grab your pump removal tool, and then just go ahead and install the pump removal tool until you can get it secured to the splines and the stator, and then from there all you're going to do is force it out. Okay, I'm seeing bits of what appear to be RTV. And it smells like RTV. I don't know why I'm seeing that, but that's what I'm seeing. Should never be RTV anywhere around the pump. Now, what this could be is just simply residual RTV from, an engine-related repair or something like that. But I don't know why it would end up, where it's ending up. All right, so that's how you get the pump out. Let's check the gasket. No RTV on the gasket. And I yank this thing off. All right, let's take a look at the pump. So you're going to have a selective washer. These are numbered. Let's see what this one is. And it looks like a number 3. Yep, number 3 washer. So number 3 washer is the most common washer in these transmissions, at least that I've seen. Okay, you may see a different one, but number 3 seems to be the most prevalent. Okay, I'll flash a chart on the screen of all the different washers and their thicknesses and the corresponding depth. And I'll talk about measuring for depth for both front end plate and intermediate clutch clearance. So that's the intermediate clutch pack you see there in the mouth of the case. We'll get our pump support tool. So 10mm on these bolts. Okay, AODs use a traditional drive-in driven gear style pump. The body's cast iron, as is the stator, or stator support, I should say. And in the AODEs and 4R70s, they transition to a gearator style pump. The gearator style pump has much more efficient flow and greater volumetric flow throughout the unit, especially at part throttle. So that's why they went to that. They also went to an aluminum housing or pump body, doing away with the cast iron. All right, so you have your return spring for your intermediate clutch. So all you need to do with this is just simply gently pry outward as you're pressing down on it to dislodge it from the pump body. Okay, and it just comes right off, and then you install it the same way. And then for reassembly, you may or may not need the special lip seal tools. Okay, and if there's time at the end of the video, I'll show them. But more than likely, I'm just going to do a separate video because there's, I don't want to say a ton of specialized tools for this transmission, but there are some. And it's more so than your like 4L60s or 4L80s. It's worth probably doing a video on. All right, but to get this thing back in, you can use either your traditional lip seal style tools, the kind that come in the kits, or the circular, I guess rubberized variety. Transtech makes them and sells them, or you can use the special tools that that Ford made available for this family of transmissions. So like anything else, you just want to check the sealing surfaces on both lip seals just to see if they're hardened, if there's something about them that would explain maybe a failure in this particular clutch, say the intermediate or forward or reverse input or whatever. These feel like new. Okay. First gear and second gear were both working in this transmission. It's just third gear that burn up, and just like the 700R4s, if the TV cable is maladjusted or the geometry is not correct, the 3/4 pack will be the first victim. So, and get these out of the way. All right, let's take a look at the gears themselves. So here's our stator support. And then you have your sealing rings. Okay, you want to check the condition of the sealing rings. These are for your reverse input and your forward clutch drum. So if you're having problems either slipping in forward or slipping in reverse, these could be excessively worn. And then when we get the drum out, we'll look at the sealing ring groove area for both of them to see if there's any concerns there. Okay, one thing you want to do with these is, you see these holes here, they're lubrication. This one here is a lubrication to your intermediate one-way clutch assembly. It's a good idea to open this up to 93 thousandths so that you can promote better flow of fluid to that clutch, especially for high RPM type applications or anything real heavy duty towing and hauling. So for you guys that have these in Broncos and pickups that like to go off-road or whatever, you know, it would be a good thing to perform some lube modifications in the transmission. And I'll do a separate video showing all the different spots that you're going to want to open up and improve fluid flow. But doing so will, you know, promote longevity and mitigate the risk of failures when it comes to the gear train and the one-way clutch assemblies, especially that intermediate, because it's kind of weak in these transmissions. So you always replace the one-way assemblies. A popular upgrade is to do a 4R70 reverse input drum swap, especially the 98 and ups that had the mechanical diode. That's going to be your best bet. All right, so gears. So your main objective here is to confirm or deny that the gears are in good serviceable shape. All right, so note the orientation. The flats are going to face the front of the pump assembly. So when you install this, your, you know, where they go flush up to the surface here is going to face you. Okay, it's okay to reuse the original gear set as long as the gear set is not worn. So you're checking for wear on the teeth. Okay, for both drive and driven gear, you're checking for excessive scoring. So this has a directional indicator. Okay, what I'm doing is I want to see if my fingernails are getting caught up on the wear grooves that I'm seeing visually. Whenever you have clutch failure, a lot of times little tiny bits of metal that are part of the you know, the fiber disc will actually end up circulating throughout the transmission. So we get into the direct clutch and we see it's absolutely scorched, and some of the friction discs have been, you know, completely relieved of the friction material. You know, it's down to bare metal in spots. Then that would explain some of what I'm seeing here. So when I'm dragging my fingernail across these gears, it's catching in this location here by the little dot. So I'm going to replace this gear set, and I may have to replace the whole pump if the pump itself is scored heavily. I mean, there's a ton of fluid in here. So let me let that drain for a second. And see if we can just wipe it off a little bit so we can get a sense for what the working surfaces look like and what the crescent looks like, because in these style of pumps, it's your crescent that is going to be, you know, your biggest indicator as to the health of the pump and its ability to generate pressure and, you know, flow the appropriate amount of fluid volume throughout the unit, especially under high throttle angles. All right, so this crescent looks good to me right now. Like I said, I'll clean it up and then inspect it for real, but you want to inspect the entirety of the crescent. Where they tend to get worn is at the edges, but they can get worn anywhere. If you have a vertical end mill in the program to recondition these things, what you would do is you'd set it up to take, and you know, I want to say it's like 30 or so thousandths off of the face of the crescent here, and then install an oversized drive gear and driven gear set. I mean, that's basically how you repair these things. Otherwise, you're looking for a good used one. So we see some grooves here. All right, the grooves may also be from a previous life. Like I said, I don't know, you know, what sort of damage or, you know, what kind of things happened to this transmission prior to that recent overhaul. And so the shop may have elected to reuse everything just because they felt it was in good shape. I don't know, it's just a guess right now. So you got your pump O-ring. Okay, again, it feels brand new, like you figure it should. My hands are really slippery. So the yellow stripe faces out. And then one more point of emphasis I'll make before we move on is the bushing itself. Okay, all the bushings should have been replaced in this transmission. This bushing does look new. It is not overly worn. So it was staked in the locations provided. So you notice the oil groove here. Okay, this groove does not go from one end of the bushing to the other. It is directional. So if you have this bushing installed backwards with a little notch facing in that direction and the oil groove terminates here at the seal instead of on the back side facing the gears, then you're going to have a whole bunch of fluid, extra fluid that shouldn't be there, pummeling the back of this seal, and eventually it's going to break through and you're going to have a big leak and loss of fluid at the pump. So you're going to see it on the ground, you know, dripping through the converter cover, or, you know, underneath and all over the converter. And if that's the case and it's a fresh rebuild, you might suspect that the pump is worn. Another thing is check the sidewall in here for excessive wear. I could see wear, but I can't feel it yet with my finger now. I'm wearing thick gloves. These are 9mm thick. I got them at Harbor Freight. But once this is cleaned, like I said, I'll go do a full 100% thorough inspection on it. And if there's any problems, then I'll need to advise the customer that, you know, he's going to need a pump. Or his customer is going to need a pump. Maybe a more accurate way of saying it. Okay, at this point you can yank out this other shaft. Otherwise it might get in the way. And this will be cleaned and inspected later. Alright, one thing that you want to take notice of when it comes to the intermediate clutch, because it's the clutch along with the two drums that are going to come out next. But the one thing you want to take notice of is this front steel. So let me see if I can pull that out by itself and then we'll look at that. So in the intermediate clutch pack for these transmissions, the front steel is selective. Okay, they have different thicknesses for this steel, so whatever you do, don't just automatically, you know, throw it to the side or toss it in the scrap bin, because unless it's completely destroyed, you know, you may need to put it back in. So you notice here it has a number 2. Okay, there's different thicknesses of steel and they're identified by the different numbers. I'll put a chart on the screen to show you what those are. But this steel looks like it's in perfect shape. Okay, and then the rest of the stuff just comes out. So you have your band. Okay, the band is brand new, looks perfect. 1.5 inches for the width. The Ford R70Ws had a 2-inch wide band and a correspondingly wider reverse input drum, at least the band surface. So one thing with this transmission is that there is a lot of bearings, a lot of Torrington bearings. So you'll need to pay extra special attention to the orientation of the bearings as well as their location. They're, you know, some of them have to be oriented a certain way, or actually all of them do, not some, all. But what I wanted to say is that they look very, very similar, you know, one direction to another. Not this one, it has a giant, you know, radius here, but some of them can be confusing. So this goes here, okay, just like that. And in the very, very early AODs, there was a thrust washer at this location. Okay, thankfully they came to their senses and decided to put a Torrington bearing there instead. Alright, let me collect the intermediate clutch. Okay, looks like factory level frictions were used. Okay, there's going to be 3 frictions, 3 steels. These 2 steels, let me go ahead and measure their thickness for you. And then I'll measure the thickness of this other one, the selective. So these are going to be 67 68 thousandths. Okay. And then the selective steel is going to be, looks like 78 thousandths of an inch. Okay, again, the number 2 is what I see most commonly as well. So it presumably is the most common kind of steel out there for this clutch that's selective. So if you need to replace it because it's completely scorched or burnt up or whatever, you should be able to find another number 2 without too much difficulty from your hard part supplier. Alright, these steels are new, so he put a steel module in here. You can reuse your steels, it's no big deal, as long as they're in good shape. I mean, that's always the overarching caveat when it comes to steel. They have to be in good serviceable condition. Because if they're not, then, well, obviously you can't reuse them. And my standard is, you know, 1 or 2 little slip marks here and there is fine. You can kind of buff those out and do some prep work. But if it's got bluing, if the slippage is extensive, then just replace it. Just put a steel module in. And you can buy individual steel, so you can do a steel module for either the intermediate or either the direct, and if everything else is fine, you can reuse that stuff. But, you know, it's all up to you. It's a judgment call based on what you see and what you observe. All right. All right, let's take a look at the reverse input drum. Okay, note the clearance. I'll post the clearances too for you on the screens. But let's see what kind of condition we have here. There was no complaints about reverse or issues with reverse. So I'm expecting no damage to this clutch. Should be in good shape. And that's assuming I can ever get the snap ring out. Okay, so you're going to have Belleville style return plates. You always want to replace these on overhaul. I don't know yet if that's new or if this was reused. Shouldn't have been. It should have been replaced. Okay, so you have your apply plate and your backing plate, and then 4 frictions, 3 steels. They are all in perfect condition. And these frictions have, like I said, probably not more than 50 miles or so on them, 50 to maybe 100 miles tops. Brand new steels. All right, you can withdraw the snap ring here. I mean, it's going to be tough. Especially considering my hands are very slippery. So this is another 2 screwdriver job. Or maybe a pick. Like I said, these are a bit tough, and they'll fight you. But that's what you want. I mean, you don't want it coming out nice and easy. Now it's stuck in the other snap ring groove. Okay, so it is waved, and that's part of the reason. All right, I don't know if he replaced this or not, so we're gonna put a new one in here. All right, so here's your feed. So you got a feed hole here and another one over here. So it's basically a dual fed clutch. And it did not come out. All right. So as you can see, these lip seals, or these, this one's actually a D-cut seal, or a square cut seal. Okay, you know, new ones are going to be very, very supple, and they're going to hold hard and fast. So you have an interior and exterior one, or inner and outer. Okay, no big deal. One thing you want to make sure that this bleeder ball is functional. Okay, that works. If not, it'll want to go forward and bind up when you put it in drive. I'm sorry, it'll want to go into reverse or bind up when you put it in drive. All right, check your band surface. As always, you want it nice and smooth. You can take your straight edge and a flashlight, shine it underneath to see if light is coming through underneath that straight edge. If so, this will have to be either turned or replaced. Okay. One-way clutch rotation is counterclockwise. It locks clockwise, and that is because the clutch basket is facing to the rear. This clutch basket was facing front. It would freewheel clockwise and lock counterclockwise. All right, so it looks as though he may have installed a spiral lock snap ring, because one of the other areas of weakness in this thing are the snap rings that come from the factory. They will pop out, especially under high RPM, high torque demand. Alright, so what I have to do is I have to kind of unhook, if you will, each of these areas where it's kind of bent inward, and unravel the spiral snap ring. Let me see if I can do it without doing that, but more than likely I'm going to need to do it. Let's see if I can get at it. This screwdriver is real thin, but it's not quite thin enough to dip under that snap ring. So I'll uncollapse these, collapsed portions of the retainer, and then we'll pull the snap ring out and we'll look at the assembly. Okay, I have to assume that he did not replace the one-way clutch. I'm sure he did, but I have to assume he didn't, just for the sake of worst case scenario. So I will install a new one in here regardless. Since this is largely a factory level build, the engine, as far as I know, is stock. It's a stock 302, and the owner of the vehicle just uses it as a part-time cruiser, or cars and coffee type deal. So he's not out racing around or anything like that. If we were doing that, we would go with a mechanical diode upgrade with the 4R70 reverse input drums that came with these. All right, so if you don't mangle it, it is reusable. The little the capture ring for the spiral snap ring, and obviously the snap ring is reusable as well. This is probably a Sonic's product. I know they have a snap ring specifically for these drums, and I don't know of anybody else that sells them, so 99% sure this is going to be a Sonic's spiral snap ring. You hear that sound? That's the sound of a very healthy roller one-way clutch assembly. Alright, so you have your outer race, and you just want to make sure that there's nothing obviously wrong with it. Okay, no excessive heat soaking, no bluing, no wear, unusual wear patterns. I mean, this thing looks perfectly fine. And here's your roller assembly itself. Okay. This looks original to me. So that's why I check. I don't like to assume that the previous rebuilder did everything that should be done. And it's not to disparage the builder, it's just more or less to protect yourself. Okay? Not every builder is going to do everything they should, or maybe, somebody will make a mistake. I mean, we're all human beings, but as the last person to touch this unit, you want to be sure that everything that needs to happen with it happens while it's in your possession. All right. Last things we'll check are the sealing ring areas. You want to make sure that there is no physical grooves cut by the sealing rings into the drum. The wear patterns are visible. That's perfectly fine, but you should not be able to feel anything here. Okay? And then while you're at it, just check the cam, the condition of the cam. It needs to be, not loose, right? Okay, you shouldn't be able to just yank it off. I mean, I could feel it a little bit when it comes to, I could see fluid reacting to what I'm doing, but it's otherwise on there, as it should be. These bushings, I don't believe, were replaced. Okay, I replaced all the bushings in these transmissions. And I have a bushing driver set specifically designed for the AOD 470, 75 family of transmissions. So those bushings look original to me. All right, let's look at the forward drum. Here's your clearance in the forward drum. Okay, you have to have a minimum of 50 thousandths clearance in this drum, because unlike many other transmissions, this is actually a working clutch. Okay, forward clutch in most transmissions is what I refer to as a static clutch or a non-working clutch, meaning that once it's on, as long as you're in a forward pattern range setting, manual low through drive or drive 4, whatever you want to call it, the clutch in the forward drum will be applied, and it won't come off until you put the thing into park or neutral or reverse. But in these transmissions, this clutch comes off in 4th gear. So if you're tight in here, you run it down to 30 thousandths like you would say in a 4L60E. Okay, you're going to drag in 4th gear. Alright, so once I get this apart, we'll inspect the splines. it's common, well, not common, but it can happen to where the forward drum cracks around here. You want to take a look at that. You have your return spring, and then your snap ring, and then of course your apply piston. And this is one of those drums where there is that special lip seal installation tool that's used to seat them and install those pistons. So you're going to have your cushion plate, and then here's your bottom steel. Okay, 5 frictions, 5 steels. A little bit of slippage there. Okay, Borg Warner. Factory level frictions. For stock to mild applications, they're perfectly fine. If you're doing high performance, you may want to run high energies or GPZ, Alto Reds, all the way up to Ray Bestis Blues if you're doing racing. So that looks okay. We see a little bit of heat on a couple of these steels. A little bit of heat marks. So we'll go in with a steel module for this transmission. I mean, you can reuse the steels if they're in good shape, but I'm probably just going to do a steel module. I mean, it's, saves me time on the prep, and steel modules aren't that expensive. All right, I'm gonna put the forward drum aside, and once we have everything out of the case, we'll bring the drums that have the the pistons still in them. We'll bring those back with the pistons out, and we'll look at lip seals. But I imagine they'll be supple other than maybe the direct drum. Okay, so here is going to be your forward hub. Note the bearing orientation. Okay, this is correct. And then on the back side you'll have a bearing. It's still there on the Sunshell Sun Gear assembly. So just check your lugs, check your surfaces, make sure this thing's not cracked. Okay, make sure there's nothing weird going on with it. Okay. You also have 2 bearings. So on the Sun Gear, you have a bearing that has, kind of like an inner radius. It seats just like this. And this surface here rides on the rear Sun Gear. And then same with this bearing. These 2 bearings are exactly the same. Again, those bushings don't look like they were replaced. So check your journal surfaces and check your gear. Okay, common sense. Check your lugs here on the shell. Make sure they're not worn. If they are, it's going to be a noisy, noisy transmission. You don't want that. Okay, center support. So you have your center support snap ring here. Notice where this cutout is. It's aligned with the overdrive band anchor pin. Guess would help if I had the camera oriented correctly. So you're gonna have your snap ring here. Okay, this snap ring has 2 upward tabs. The 475s, this design changed. They eliminated one of these upturned ends to allow for the input speed sensor that was installed into those units. All right, here is your rear sun gear and intermediate shaft. Okay, this has a captured bearing there in the planet. So when I get the planet out, you'll see that. So just check your surfaces for gears. See if you can see that. It looks like we got a chipped tooth right there, so this will not be going back in. I'm just scrutinizing it to make sure it's not some sort of like manufacturing indexing mark. Doesn't seem to be. I have not seen indexing marks on these, so that's no good. And no idea if that damage was present during the time of the last overhaul or it happened between then and now. My guess is that it was there, given the what little amount of driving occurred before this thing came off the road again. Alright, now what I need to do is turn this case around so that we can get access to the output shaft, so we can smack on it a little bit and then bring forth everything else out of the case. Okay, so in addition to the gear set, you're going to have your direct drum back here. You're also going to have your low reverse band and a stabilizer ring or anti-fretting ring for the band. Okay, so you can just bring everything forward. Just kind of be careful. And again, slippery hands. So you have your anti-clunk spring. And the little ends will face the case. There should be a little wear mark right where that went in the case. I'll see if I just get a picture of it. It's going to be very difficult for me to get the camera in there real close, but alright, so now we have the rear gear train and direct drum out of the case. We can start to look at those. So here's our center support. Center support bushes onto the planet, and then you have your low roller assembly. So just simply spin it counterclockwise and lift off, and it'll come right out. So just on the center support itself, check the inner race for wear. And then of course your bushing. This bushing does not look like it's been replaced to me either. So we've kind of seen a pattern of bushings not being replaced throughout the unit so far. And same with this one. I mean, just at a glance, it looks like it was also reused. So now some builders feel that you can reuse bushings as long as they check good. So in other words, if the bushing has a specification between it and the bushing, whatever surface it mates to, and you can measure that somehow, then you can reuse it if it's in good shape, otherwise not damaged or marred in any way. This is true for a few different types of transmissions. The FMX, this transmission's predecessor in particular, you more or less have to use that kind of approach because those bushing kits are not available anymore. And as far as I know, there's nothing in the aftermarket bushing kit wise to replace them. So if the bushing's not in good shape, if it's just worn out and there's play, like for example, when you take out something like a low roller clutch assembly and you want to measure the bushing for play on the workpiece. And here I'm separating the little rollers here. That sometimes happens. We're not going to reuse this roller assembly anyway, but you can install this on and check it with a feeler gauge. Okay, you can check how much play you have between the bushing and the workpiece. All right, this has some side play to it, a little bit anyway. If it's within whatever spec that exists for it, and like I said, if it's otherwise not excessively worn or damaged, you can reuse it. And some builders will prefer that approach because there's issues sometimes with aftermarket bushings. Aftermarket bushings that come in the kits from TranStar or wherever will be either too loose or otherwise out of spec, and I see this every once in a while with some of these older units. And so the original bushing is sometimes the better option to just leave it in. So anyway, that's the deal with bushings, and also an explanation of why the previous builder elected not to replace the bushings. Maybe because I don't want to say he's lazy. Maybe there was a rational explanation, a reasonable explanation, and a thought process, and what I just explained would be that thought process. All right, we'll scrutinize the planet first. Straight away we see some wear here on the band surface. It's dirty obviously, but what you're looking for is anything you can feel with your hands. Okay, and I'm feeling this, and it feels a little warped to me. Okay, in fact, let me if I can wipe it off, make it a little bit more discernible. All right, so something passed through here, some sort of metal, and then there's visible and physical wear on the surface itself. And we already have the longest servo pin, I believe, that's available for these units. So turning this is probably not the route we could take. We might have too much band clearance at that point. So I have a few good used planets for AODs in my inventory. So what I'm going to do is once I clean this off and have an opportunity to take a really close look at it and compare this with them, if they're markedly in better shape here on the band surface, then I'm just going to swap the planet. And like I said, this one is for all intents and purposes no good. So unfortunately it will be a hard part cost that I'll have to assess to the customer, but it is what it is. All right, here's a band. So the band is a bit worn, not terribly. Looks like we got a wear spot right here. I could have done that taking that out of the case, or it could have been pre-existing. I don't ever reuse these double wrap bands. I always replace them. I treat them no different than any other friction element. In my opinion, all transmission rebuilds, any of the friction elements should never be reused unless there's like an extraordinary circumstance that requires it, but I don't think I did that. I think this is just band wear, and like I said, some shops will reuse the bands if they're in good shape. And the reason why a shop would choose to reuse this is because this surface may have been worn in this transmission's previous lifetime prior to coming across the previous builder's bench. And so because we have wear bonding between the band and the band surface, he did not want to disrupt that wear bond with a new band. And while there is some wear to it, there is plenty of meat on the bone here. There's plenty of friction material. So he may have made a judgment call to say, okay, I don't want to disturb that wear bond. If I do, the new band will just prematurely wear much more aggressively. Let me reinstall the pre-existing band, and reverse will continue to work without issue. All right, last thing in the case, or last two things in the case, are going to be the rear stabilizer ring or anti-fretting ring. Okay, this goes in behind the band. And then our case bearing. So rear case thrust. So this goes right here. And it's an open style bearing, or bearing half like this. And it just sits like this. And then the mounting flange mates with the flange on the case. Alright, now we have our direct drum. So let's take a look and see what, if anything, happened to this clutch pack. Again, we were neutral in third gear. There was no 2-3 upshift whatsoever. It was neutral. So I guess I shouldn't say there was no, it was happening, but it was in neutral. Alright, so the first thing I want to do is take out the clutch hub, the bearing, and the spacer. So just turn it upside down, and those three things will come out. So you're going to have a spacer that goes inboard, and then you're going to have your bearing, and that's orientated just like this. And then your hub. So scrutinize the hub, make sure there's no cracks, fractures, make sure the splines are not worn. Okay, the structure should be in good serviceable condition. Every once in a while these will come in cracked or damaged. That's usually due to some sort of like catastrophic failure in the back of the unit. You know, due to either overheating or just, you know, hard launches on racing and things of that nature. But for the most part, I don't see that hub broken or damaged or anything like that. Alright, here's the washer, your spacer, and then your bearing. Alright, these bearings are fine to reuse. That's bearings everywhere in the case, as long as they're in good shape, as long as there wasn't any massive overheating. If they were subjected to a lot of heat, or, you know, they're blued or whatnot, then I would just replace them. Alright, so in order to get the drum out of here, what we need to do is take out the snap ring here. That secures the output shaft flange to the output shaft and then to the ring gear and / parking lug. So this snap ring can be stubborn as well. I mean, it's tough. It's designed to, you know, retain everything in here. In fact, let me see. What I'm looking for here is my 45-degree angle pick. I'm going to get at it with a screwdriver. Alright. Alright, so here's your flange output shaft assembly with your sealing rings for direct. Because we had a neutral condition, we want to scrutinize these. They're scarf cut, meaning you don't need to resize them. And they look fine to me. I mean, certainly nothing that I'm seeing would explain the neutral condition. So, put that there for a second. We'll come back to the shaft in a minute. So let's take a look at our drum. So just turn it right side up like this. Separate your ring gear basket from the direct drum. Alright, the first thing I want to do is scrutinize these splines. So we'll bring back our direct shaft. Okay, this has a little bit more than normal wear. What I'll do is I'll test fit this shaft to a couple other drums I have, and if they're noticeably tighter, then I'm just going to swap out the drums. I'll have to charge the customer if I cannot find a shaft that will mate to this drum and mate, you know, a little bit tighter. So these are prone to stripping the splines here because these splines don't go all the way to the top. Alright, so it is an area of weakness. And then the other thing concerning the shaft, and I didn't mention this earlier, but I'll mention it now, is these shafts are also prone to excessive wear here at the ends. Okay, if converter ballooning occurs, you can tell because there'll be a divot in the center of the shaft. So if there was a history of converter ballooning in the transmission, it'll show up there. And we can just check. Yeah, I'll have to look around and see what I have. So, I mean, I just tested both ends just for the hell of it. Okay, let's take a look at the direct clutch. As you see, it's got quite a lot of clearance in there. So I'm expecting these to be burnt. They are not burnt. So 5 frictions, 5 steels, and your backing plate. The subsequent AOD E4R70s improved upon this clutch pack a bit. The AODs, they saw the introduction of these stamped steel clutch basket style drums in 90 or 91. If this is original to the unit, then obviously it'd be 89. But I don't know if they were installed at the factory in the 80s or not. I'll have to do a little bit more research and see if that's the case, or if this could have been just simply a swap from a later unit because of a hard parts failure. And again, the cast iron drums have a much higher failure rate than these drums do in the AODs. So your bearing is going to go like this. Alright, the open side with all the needle bearings is going to face your flange. And there's basically the race. And like I said, we'll come back to that in a second. Okay, these steels look new to me. So a steel module was put into this thing, and these direct steels are like new, as are the frictions. So there's got to be some reason that there was a no apply situation, or nothing was happening when transmission was presumably trying to shift from 2 to 3. Now it's also possible that I may have misunderstood the shop owner, and where he was telling me that he told me neutral and third, but it could be a no upshift condition as well. And if you wind up second gear high enough in terms of RPM, it could start to feel like neutral. But he'd have to wind it out pretty good for that to happen. It's not like first gear. First gear will feel like neutral once you go beyond about 2,500 to 3,000 RPMs. And, that's going to be a little bit different. It's a lot easier to produce a kind of quote-unquote neutral and third condition. Neutral and third condition when it's a first gear back shift than it is for second gear. All right. So for your ring gear basket / parking gear, just double check in here and make sure that there's no damage. Okay, remember the drum sits in here. So if there's some destabilization, you might have wear like this. It's making contact with the sidewalls. So I see a little bit of that. Or at least something may have passed through here. Okay, check these lugs, make sure they're okay. Check your engagement lugs and where the where the hub meets the basket, and then check your splines. I'm sorry, your teeth. Okay, no chips, no fractures, no excessive wear. All right, let's come back to the output shaft. So you have your 4 sealing rings here. They're metal, and they're the click or interlock kind, so fairly easy to deal with. Alright, so you got to take these rings off before you can separate the hub from the output shaft. And it doesn't really matter if you break them, obviously new ones will come in the kit. Alright, that one wants to give me trouble. Alright, now you have your snap ring that holds the output shaft flange to the shaft itself. So for that I need my 90-degree pliers. And then I'll just switch over to these to get it the rest of the way off. Alright, so just carefully remove the hub from the shaft. And then, like all other gear train parts, you're checking splines, you're checking engagement lugs, and you're checking the bearing surface. So you have your case bearing, and like I said, that sits right here, and then just more or less mounts to the rear of the case in that location. Okay, check this this bushing surface, this journal. All right, you don't want to see any issues there either. This appears to be in good shape. Oops. All right, last thing that we're going to look at is the rear case bushing itself. To get that out of the case, you're going to need a blind hole puller, preferably a collet style puller. Rotunda or OTC, they make a special tool specifically for these rear case bushings in the AOD 4R7075W transmissions. I've been looking for it for a while. I couldn't, I haven't found it yet. Usually all these special tools are purchased on eBay, but that particular tool I have not come across. And for DIYers, you really don't need it as long as you have something to yank out the bushings. But I like to have the special tools just because they're purpose built for that particular application, and it makes the workflow more efficient and reduces risk. But from a DIYer's perspective, how many of these are you really going to do? Is it worth it? It depends on, I guess, how much the tool is, but some of the tools for some transmissions are very, very, very expensive, and it just may not be worth it for you to purchase them. Alright, we have most everything cleaned off, at least the big stuff. I still have to clean some of the small crap, but we're going to take a look at a few parts in a little bit closer detail because I didn't really touch on them in a way that I wanted to when everything was still filthy. This is the following day, so I had a chance to clean everything off, and now we can scrutinize some of these more important parts that either directly or indirectly may have either directly caused or at least influenced that neutral in third condition. All right, first we'll take a look at the pump itself. So now that it's cleaned off, we can see some wear, just some physical wear patterns here at the base of the the pocket. But fortunately, I can't actually feel any drag when I'm running my fingernail across it. Okay, and I actually did this with bare hands, but I'm wearing my gloves now. But we have an ever so slight bit of wear here at the edge of the crescent. So I'm going to take this to my machinist to see what his opinion is. I don't think this is going to be a big deal. Like, in other words, I don't think this will need reconditioning, but I want to get his thoughts and see what he, see what he says. So we have a little bit of wear here and a little bit of wear right here. But the sealing surfaces here for the intermediate clutch piston look and feel perfectly fine. The rest of the pump looks fine. The pump body, I should say. I still have to knock the seal out and the old bushing. I think that the builder replaced this bushing, but I could be wrong. To be honest, it's like hard to tell. I mean, it's got some wear to it. Maybe a little more wear than you might think that a bushing with only 50 miles has on it. But there could have been particulate matter too in the system from the previous, the previous life of the transmission before the builder that had rebuilt this in 2022 got to it. And so if that, that system wasn't properly cleaned out, there's going to be residual crud and contaminant, and it's going to circulate throughout the new transmission, and that's the last thing you need. So for all my rebuilds, I provide a sheet that literally says in big, bold stop sign graphics, hey, stop. Before you install your transmission, make sure you flush your system out, your lines, your coolers, everything. Make sure that it is completely free of contaminant from the previous, transmission, or from the failed transmission and all the crud that accumulates, especially if you have a torque converter clutch failure. Okay, that's a guaranteed comeback if the converter clutch just disintegrates, because it's going to contaminate and restrict and clog your system. It's guaranteed. So that's the pump body. So here is the stator and stator support. Okay, we have some scoring, and unlike the pump body, the wear pattern is something you can feel. It's not just visible. I mean, it's not too bad, but it's pronounced more so in this location than it is here. But there's, something was circulating in this thing. Even if it was just for 50 miles or so, it was enough to score up the surface, at least in here, or on the stator support. And same with the gears. Okay, if these gears are new, they're scored up pretty heavily. I make you feel this here, so a new set of gears will be installed. Alright, now let's talk about what I believe is the cause, the direct cause anyway, of this neutral in third condition. So the transmission was shifting from first to second, and it did upshift from second to third. Okay, I did check the valve body to see if there was anything unusual about it, but in terms of stuck valves, however, everything seemed fine. And I think the root of the problem here is the excessive clearance in the direct clutch. Okay, so I have the clutch pack all back in, the drum reassembled, and everything back installed, the old lip seals and all that good stuff, so that we can air check it and measure a clearance. Okay, because we have a lot of clearance in this thing, and I remarked, I was kind of amazed and taken a little bit back by how much I saw when I first pulled it out of the case and started looking at it. You should have between 50 and 70 thousandths clearance in the direct clutch. So I think we have more than that. How much, I don't know, and I want to measure it. So what you could do is, with the direct drum fully assembled and sealing rings installed on the output shaft here for the direct feed. Just go ahead and insert. And then you're going to bring up your feed passages here on the output shaft, and it's going to be this one here, the inboardmost feed passage that's a little bit smaller than the other two. That's going to be your direct clutch feed. Alright, so what I'll do is I'll also insert the direct shaft, because otherwise air is going to come whooshing out of the loop passage up in here. So, I mean, if nothing else, it's just kind of distracting. But basically what you're going to do is you're going to just put air here. And you can apply the clutch. Alright, so what I'm going to do is I'm going to take this thing over to the foot press. We'll bring the camera over, set up a dial indicator, and I'll measure the clearance there, and we can see what we're working with. I mean, it looks like a lot to me, but you know, who knows? We'll put the dial indicator on it, and we'll see how much travel we actually have in that clutch pack. Alright, we have the dial indicator set up, and now we're going to go ahead and do a clutch clearance check. And I know I said that we'd go to the foot press. This is the vise. I meant to say vise. You go to the foot press. There's nothing to hold the output shaft in place underneath, so we need a vise. Alright, let's go ahead and put some air into the direct clutch and see what kind of clearance we have. Okay, not quite returning to zero, so let's try it again. So about like stopping about 3,000 to 4,000 shy of the zero. I'm not really sure why, but that's what's happening. Okay, that looks like it's either 1,000 shy or right at zero. I can't tell from this angle. Let's hit it one more time. Okay, 90 thousandths. What I was trying to do was grab the clutch pack to see if I could move it. I mean, by hand it would be next to impossible even with this much clearance, but it looks like we have 90 thousandths clearance in this pack, which is 20 thousandths more than the maximum specified amount of clearance that it's supposed to have for V8 applications. So this, no doubt in my mind, played a role in, you know, producing that neutral and third condition, but I don't think this accounts for all of it. So when I spoke to the shop, the tech told me that when he tried to adjust the TV cable, he had third gear like momentarily, and then it went into neutral. And this was after he adjusted it as optimally as he could. So that's why at the outset of the video, I thought that this pack was smoked, and I was a little surprised to see that it was in good shape. I think some of the friction material we saw in the pan came from here. I think some of it came from the forward clutch, and maybe a little bit of it from the low reverse band, because that looked pretty worn to me. The previous builder looks like he reused that band. And like I said, you know, and I mentioned this in all my videos where we have dual wrap bands and whatever transmission we're tearing down, and a lot of shops will consider that a hard part and they won't replace it unless it's worn. So anyway, I think the causes here are multifactorial, and I think a maladjusted TV cable by the original shop that installed this thing after it was rebuilt played a role. I think how this clutch was set up has played a role. I also suspect that the boost valve in the valve body is worn out. Okay, with these AODs and, you know, the Ford C6s, etc., that use these kinds of pumps, there's no valving in the pump. The boost valve and pressure regulator valve are both in the valve body. So I haven't taken that apart yet. I don't have a test plate for that, you know, as far as like vacuum testing and whatnot. But I'm going to see if I could test it by maybe fabbing up like a piece of plexiglass to use as a, you know, some sort of improvised testing device, and run it on the Sonics tester. If I'm successful, I'll film that, obviously, and you'll get to see that. But I think that that boost valve is probably a little bit worn out as well, or maybe even misassembled. I mean, I don't know. I don't know if the the shop that went through this thing in 2022 actually overhauled the valve body at all. Sometimes they don't. They just simply put them in a parts washer and solvent and clean them with kerosene or some other non-water based solvent, and just check all the valves, make sure they're moving and stroking back and forth and nothing's dragging or hanging up, and they call it good. That's not the way I do things. I prefer to take them all out to make absolutely sure, clean all the crud out of the valve body casting itself, and when I go back with it, I always install updated or upgraded boost valves, because it's common for these transmissions that have 40, 50, 60 years of life in them to be worn there. And you don't want to put something like that back into a unit, especially if it's going into a vehicle where the engine is making much more power than a stock engine would have been making at the time the transmission was produced. So anyway, I think those are the factors. I still have to cut the filter open. I will put a tech note in the video because I'm not going to have time to do it before this video ultimately goes into production, but I'll put a tech note in the description if there was anything noteworthy in the filter. And I'll also make mention if there was anything that my converter builder found when he takes the converter apart. He hasn't gotten around to doing it yet, but that should happen in the next day or so. Alright, just want to cover a couple things before we adjourn. So we'll take a look at the lip seals on the direct piston as well as the forward piston. So we only have one lip seal on the direct, and that's the outer seal here, and what I'm looking for is anything unusual about it. So any indications that it's damaged, or otherwise allowing fluid to blow by. I don't see anything. I mean, it feels soft, supple, like a brand new lip seal should. So, but you want to scrutinize it for little tears, little rips, anything like that that would lead you to believe that it wasn't, retaining fluid or wasn't sealing. But we saw the clutch apply; it seemed fine. This bleeder ball we want to check. Okay, it's moving around, so it's working. That's how you know. Okay, same with the little lip seal on the interior of the drum, the stator, if you will. The lip faces down, so you just want to check that. Make sure that it's also supple. And then here too, you want to scrutinize this area for wear. Right, let me wipe this off. Now that I'm looking at this, I think this is a little bit worn out. So I can see a groove here and I can feel it. To what extent that's focusing, I don't know, but I'm gonna put a different piston in here. Alright, here is the forward piston. So 2 lip seals. Both feel fine to me. Both look fine. I don't see any kind of like physical damage or anything like that. And the only reason I'm checking is because it looked like there was a little bit of slippage, but that could have certainly been maladjusted TV cable, just not optimized, so we had a little bit of slippage. And it, whatever slipping did occur looked like it occurred only momentarily. So the clutches were fine. I mean, they look brand new. One other thing that I made mention earlier in the video, and I'll kind of circle back to it, is the relationship between the male splines on our direct shaft and the female splines in the drum. Alright, I mean, this is okay, but I have a bunch of spare drums and a bunch of spare shafts, so if I could find another shaft drum combination that's just a little bit tighter, then that's what I'll roll with, and I should be able to do that. So always scrutinize this area here. If there's wear that you can feel, you want to replace the drum. Okay, I could see the wear, but I can't feel any wear at the sealing ring area on either the inboard or the outboard sealing ring. Okay, and same with the stator. And I didn't mention that. I should have done so. While there's no sealing rings on the input shaft, you still want to check, because what you're looking for are any kind of cracks that aren't visible on the outside. Alright, and in our Planet, we're going to replace this and the corresponding rear sun gear and intermediate shaft combo, and that's because we just have chipping of the teeth. I'm not going to put something back in that has chipped teeth. Okay, and the band surface here is kind of beat up a little bit. You know, I can physically feel grooves. It's a little warped. So if we want to install a new band, then we want this surface to be nice and smooth and not warped. Okay, could be that the previous builder decided to reinstall this, like I mentioned earlier, because you know, the pre-existing band had already wear bonded to the warpage of the drum, so there was no complaints about reverse engaged just fine. So you can certainly just, you know, do that if you're like on a budget or you're in a jam and for whatever reason you just can't get access to another Planet. But because we have access to other Planets and we have access to new bands, we're gonna put a new band on a fresh surface, and that's the right way to do it. All right, as far as what we're going to do with this transmission, it's going to get a complete and total overhaul. So new cowl kit, which is your paper and rubber, your filter, your overdrive band. I'm going to put a heavy duty band in here for overdrive. I don't like using the stock band. We're also going to put a new low reverse servo and cover, new 2-3 accumulator piston, obviously all new sealing rings, lip seals, scarf cut, you know, or otherwise. Gaskets and all that good stuff, you know, the common sense stuff. It's also going to get a new Belleville plate for the reverse input. We're going to machine the pump cover, get that perfectly flat, put the aforementioned Planet and rear sun gear intermediate shaft. We'll look for those good used. I'm going to see if I can find a more optimal combination for drum and direct shaft. If I can, then we'll just swap it in. I won't charge a customer, because usually I can make all different combinations work just by, you know, trial and error. New one-way assemblies, we're not going to reuse those assemblies. I mean, I don't think they were replaced, but either way, it doesn't matter. They'll get new bushings everywhere. I'm going to purchase a new Sonic spiral lock ring for the intermediate outer race. I kind of, you know, butchered or just mangled that retainer plate, so you know, I'll replace that. Don't want to put that back in. What else? Transgo shift kit will go into the valve body. Sonic's boost valve. I like the O-ring variety. Sonic's does make a non-O-ringed boost valve kit for like real high performance or very heavy duty towing hauling. It's like a much larger ratio boost valve. It's not necessary in this application, but if we were doing something like that, then that's the part I would use. New gears for the pump. Those gears are worn out, got a lot of scoring to them, so I don't like that. And then I think the other thing I'm going to do is I have to dig through my bin to see if I have other selectives for the both the intermediate clutch, you know, that first steel, and the pump washer. So if I don't, then I'm going to just go and grab a couple extras, just, you know, different thicknesses, so that I'm prepared in the event I need to make adjustments for both the intermediate clutch clearance and the front end play. So I'm going to film this whole rebuild, so you'll get to see this thing go back together, and you'll see all the different special tools we use and all the different procedures that are, you know, idiosyncratic to this transmission. And you know, hopefully it'll be a good reference video series for you if you have an AOD that you're looking to rebuild and maybe you're not familiar with, you know, that transmission. So all right, that about does it. Thank you so much for watching. I really appreciate it. If there's any other parts I missed in my you know, list of everything I want to put in this thing, I'll annotate the video, but I think I covered everything I want to cover. Oh yeah, no, As soon as I say that, I realize I missed one part, and that's the alto power pack we're going to put in a direct drum. So always beef up your direct drums, and use an alto power pack is a great way to do that. It'll allow us to put an extra friction and steel. For your 470Ws, I think you can put an extra 2 or 3, and either way it makes it that much stronger. So as always, thank you so much for watching. If you have any other questions, comments related to AODs, or you want to see a topic explored in more detail, please let me know on that, and I will make it a priority to film a video. Until then, enjoy the rest of your day or evening, and we will catch you on the next one.